Hello everyone and welcome to Network Playroom. So in this video we're going to do a lab on OSPF authentication. So in my previous video I talked about the three different types of OSPF authentication that are available. And let me repeat those quickly. So type number 0 is null authentication, which means that no authentication is used. Type 1 is clear text authentication, and type 2 is cryptographic authentication, which now refers to both Md5 and SHA authentication. And we will configure these different authentication types in this lab video. So let's go over to R7. Let me actually show you the topology that I'm using. This is from INE, and I'm actually running this lab on Viral. And if you want to do these labs on your own, you can find the INE Viral files on GitHub in this address. So you can download the whole folder here and then just fire up a simulation from Viral. So let's do some basic verifications before we get started. So let's check on R7. So let's just do a show IP interface brief. So we can see the IP addressing is configured. And then let's check the OSPF neighbor status. Oops, it's not neighbors, it's just neighbor. There we go. So R7 is adjacent with R9, R6, and R3. So let's see if that matches our diagram, and it does. So let's just do a quick ping test as well. So let's ping R9, 79.9. And then let's do the same with R6, so we can see we have basic connectivity. By the way, for this lab, I've used the basic OSPF routing configuration, or the Viral file, if you want to repeat this lab on your own. Okay, so we have basic connectivity and OSPF is configured. So there's no authentication at the moment, which is essentially type 0, which I just mentioned. So that's the default method for OSPF routers. They use no authentication. So now let's first configure simple or clear text authentication between R7 and R9. And from the diagram, actually not from this diagram, but R9, R7, and R6 are in area 2. So let's configure OSPF authentication under the area. So if you remember, there are essentially two ways to configure OSPF authentication, either at the area level or the interface level. So now let's go under the OSPF process and then configure authentication for the area in here. And one thing to note here, remember from my previous video that SHA authentication is not available to be configured under the area. You can only configure it on the interface. And that you can see here as well. So there are only two options available for this command. So either area 2 authentication, which enables clear text authentication, or area 2 authentication message digest, which enables Md5 authentication. But we'll do the simple one first. And now that the OSPF authentication is enabled for this area, you should see the neighborships go down because they don't have authentication enabled and we haven't even configured the authentication key. So let's just give it a moment. I'm hoping I have logging enabled. That could be another thing. And the hello timers. The dead timer has to expire. There we go. Now you can see that the neighbors have gone from full to down. So now let's go to this interface. So interface gig 0/1.79, and then we'll configure the key here, IP OSPF authentication key, and let's configure it as simple. Okay, now let's jump on to R9. Let me just check here the information. Now this time, let's configure OSPF authentication directly under the interface. So we're not going to go on the OSPF process and configure it to the whole area. So oops, that's not going to work. I need the interface there. There we go. So IP OSPF authentication. This enables OSPF authentication or clear text authentication under the interface. And then we configure the password here. Authentication key and simple. So soon we should see the neighborship come back up. And there it is. So that's really how you configure clear text authentication. Simple, right? Now let's move on to Md5 authentication. And let's do a couple of debugs so you can see what happens when the authentication types or the passwords don't match. So let me do a debug on here. Do debug IP OSPF adjacency. So now, if we remove the authentication command and change it to Md5 authentication, message digest. By the way, here you can see the different methods to configure OSPF authentication under the interface. So now you can actually see the message here. Mismatched authentication type, input packet specified type number 1, we use type number 0. So if you remember, type number 1 is clear text authentication and type 0 is no authentication. So since I've removed the command, we're not using any authentication at the moment. But right now I'm going to enable Md5 authentication and let's see what happens. The message should be the same, but only the type should change. And that's exactly what you can see here. Now we're receiving clear text authentication, but we're using type 2 or Md5 authentication. And let's do something here. So let's enable Md5 on this router and this interface as well. So let me remove. Yeah, actually, this was configured under the area. So if you remember, if the authentication type is configured under the interface and under the area, then the interface level configuration will override the area level configuration. So let's do that exactly here. So now let's enable MD5 authentication under the interface while clear text authentication is still enabled on the area. So IP OSPF Authentication Message Digest. Oops. And now, here is something too important to note, and I mentioned this in my previous video as well. So a common mistake is to assume or mistake that the authentication key that we've configured for clear text authentication works for MD5 authentication as well. So, oh, this is generating a lot of output here. So if we quickly do a show run interface gig 0/1.79. So you can see that the authentication key is configured. So if you look at these two lines, it looks like the authentication is working. This is a common mistake. I've made this myself sometimes, thinking, oh, the authentication is enabled and the key is configured, why it's not working. But the command that we're using is not correct. So what we have to use is IP OSPF Authentication. Actually, I can't remember the exact command, so let me go into my example configuration. Okay, so it's IP OSPF Message Digest. Message Digest. And then let's use key ID number 1, MD5, and then we'll use MD5 key. Okay, now we've configured the MD5 key on R9, but now you can see that the message has changed. So now it's mismatched authentication key because there's no key configured on R7 yet. So let's IP OSPF Message Digest, and let's do something different here. Let's use key ID number 2. So you can see that these key IDs have to match as well. So even if we configure the same password, it's not going to work. So MD5 and MD5 key. So let's jump back on here. So you can see here now that it's saying, oops, that the neighbor is using key ID number 2 and we're using key ID number 1. So the neighborship is still not up. But we're going to fix that now. And we're going to change the key to number 1. And we should soon see the neighborship come up. And there's the message. Now these neighbors are adjacent. Okay, I can turn off the debug because it's generating a lot of output. But yeah, you can see that here as well. So let's recap a little bit. So a couple of things that we just proved here is that the interface level configuration does override the area level configuration, and the key ID and the password must match for Md5 authentication to work. Okay, now finally, let's configure SHA authentication between R7 and R6. So this configuration is slightly different, and as you can see from the example, we need to configure a keychain first with the key ID and the key string and the cryptographic algorithm that we want to use is defined under the key. And then that keychain is referenced under the interface. So let's do that. So let's configure the keychain and then key number 1. And similarly with SHA authentication, the key ID and the key string must match for it to work. Okay, so then the key, I know that looks like it's saying SHAKEY, but what I meant is SHAKEY. So key string SHAKEY, and here you define the cryptographic algorithm. I like to type out my commands, but you could just easily use the tab to complete the command. All right, so let's use 256. There we go. And then let's go under the interface. Interface gig 0/1.67, and then apply the keychain under this interface. Just like that. Actually, we could do a debug here as well. Debug IP OSPF adjacency. And now let's jump on to R6. And then let's do the same thing. Keychain. This is locally significant, by the way, so I could use a different name here. Let's say OSPF keys. And then, but this part has to match. So key ID number 1 and then key string SHAKEY. And then we'll use the 256 algorithm. So like this. And then we go under the interface. '67. Keychain OSPF keys. And let's see what happens. There we go. R7 and R6 are now neighbors. Okay, this is generating a lot of output again. Let me do a UAll to undebug everything. So here you can see that R7 is adjacent with R9 and R6. Let's just see some protocol details for OSPF as well. Let's see what's going on here. So you can see here the router ID for R7 is 150.1.7.7. And let's do the same for these two routers as well. Right here. This router is neighbors with R4 and R1 as well. And this is because I've used the viral configuration file. So this is something I didn't configure. It was already configured for me. So let's see that our pings still work. Actually, what IP addresses were they using? There we go. So that's how you configure and verify that the authentication is working. It's always fun to do pings. It's a basic tool to verify connectivity, and it's always nice to see those exclamation marks to know that your lab is working. But yeah, that's it about OSPF authentication. I hope you found this informative, and thank you for watching, and I'll see you in the next video.